Hello, this is Sam Benson, and I shall be covering section 5.4 in the McGraw-Glencoe Hill Algebra 2 textbook. Now, this section deals with complex numbers, or I, which is the square root of -1. So if you were to square I, you would get -1. Now, addition and subtraction with I works the same way as with other variants. So you say you had 8i minus 5i or 7i plus 2i. You would get 3i and 9i. Now let's say you were to multiply those. You would then have 27i squared. Now because it's an I squared, and I squared equals -1, this will turn into a -27. Now a little trick to know is that if you have an I to the 40th, let's say, and you need to reduce that, you may think, oh, it's divisible by 2, so it's a -1. Well, a little trick to remember is if it's divisible by 4, you get a 1. So that's one thing to keep in mind. Now, say you have a variant like x squared equals -64. Well, now you can deal with equations like this. Because then you would just take x squared equals the square root of -64. Now you get x equals 8i plus or minus. Now multiplication is a bit different. So say you have 5i times 3i. That would equal 15i squared, which again would end up as -15i. Okay, now let's say you have something like 2 minus 3i times 5 minus I. We basically just FOIL these. So 2 times 5, 10, minus 2 times -i, -2i, minus -3i times 5, minus 15i, minus 3i times -i, or 3i squared. So then you reduce it, so you have 10 minus 17i plus 3i squared, which you can reduce even further to 10 minus 3 minus 17i, which would end up as 7 minus 17i. Alright, so now on to dividing with complex numbers, or I. So let's say you have 2i divided by 3 plus 6i. What you then do is you take it, 2i divided by 3 plus 6i, and you times that by 3 minus 6i and 3 minus 6i, which is basically the inverse of the bottom, and you times both the top and the bottom by it. So then you would end up with 6i minus 12i squared divided by 9 minus 36i squared, and then you reduce it. So this would equal 6i minus or plus 12, and then you would have divided by 9 plus 36. And then you can add that. So you have 6i plus 12, and then 9, no, not 9, but 45. Okay, so then you have 4 over 15 plus 2 over 15i. And there you have it, section 5.4 from the Glencoe-McGraw Hill Algebra 2 textbook.